Okay, welcome to Module 7, Regex and Parsing. Today, and we're going to be more focused on the Regex side of things because in previous models we've already went over parsing a lot. I'll still be covering parsing today, but more focusing on the Regex side of things. You know, what is a reject? What does it look like? What does it do? So, to begin, we're going to be installing the necessary tools that we're going to need for this lab. So, begin by updating the package list, and then we will be installing grep. Probably already have grep, but it's good just to run it again. Awk, sed, and core utils. Core utils gives us stuff like cut, sort, unique, stuff that we're going to be using later on that you will get accustomed to. So we'll just install that, and then we'll begin. So the first thing that we're going to do, don't worry about that awk thing. Don't worry, it's fine. Awk still works. So the first thing that we'll be doing is sudo journal ctl-f just to see the logs live, how they update, because we have to generate some failed login attempts again. If you're not sure about any of the commands I'm using, you can go back to module 5, or you can have a look at the GitHub as well. A lot of useful stuff on there too. So we're going to then open a new terminal. You can see at the bottom we have the live logs. So we'll be just generating normal SSH login attempts. From module 4, we opened the SSH port. If you don't know how to do that, you can go back and watch module 4, or just run sudo apt install OpenSSH server -server, and it should just open like that just fine. So the first thing we're going to be doing is SSH, and we'll just make up a name like hacker at localhost so that we're targeting ourselves. Simple as that. Enter the wrong password, and you can see that the failed attempts are coming in at the bottom. You can see just here that they're coming in fine. You can also note that if you look at the from section, you'll see ::1. This is the IPv6 loopback address saying this is us, but the IPv6 version. We want IPv4 as well. We want both because it's better to show when we get onto the Regex side of things. So to generate IPv4, brute force attempts, we'll have the SSH and then -4. -4 flag, it basically just forces IPv4, and you'll see at the bottom in a minute, the IP address that comes through will be 127.0.0.1 because we're trying to SSH into our own machine. So we'll use the username hacker again, and we'll go to localhost. And you'll see, when you look at the bottom, you'll see that the IPv4 loopback address is the one that's being logged. That's good, that's what we want. So now that we've generated our login attempts, that's all we want for now from there. We are next going to be running the command sudo journal ctl -u ssh.service. So we're basically just filtering. So this, if we ran this normally, it would show us just the SSH lines. This is basically just filtering the logs for only the lines that are SSH. This would be the ones that we've just generated, as you can see above. These are, an intruder, simulating an intruder trying to get into this machine through the SSH port. So then what we're going to do is something we've done a lot in previous modules. We're going to be filtering for the lines that contain failed password. It is necessary that you write it the way I've wrote it, the capital F, the lowercase p, because this is how it looks in the logs you'll see here. If the grep command is case sensitive, especially in this case, so if you didn't write it correctly, then it wouldn't return anything. The next thing we're going to be doing is we're going to pipe it into the regex. So what we're going to do is we're going to write grep again, -E, and then O. So the -E, it runs regex and only prints the match. That's what the O does. So the E runs the regex that we're going to be attaching to this command, and the O only prints the lines that match the regex. Now, here is what the regex looks like, and I will not be typing the regex, and I advise you don't either. And the reason for this is, if I can make it a little bit bigger, Regexes are quite complicated, so hang on a minute. How this one works, essentially, is you don't have to know how they work. You just need to know what they're for. So this one will select numbers between 0 to 9 and repeat it 3 times and then put a dot, and then it will repeat 3 times is what that means in the 3 in the braces. And then the last 0 to 9, 1 to 3 is for the last numbers. So we know that an IPv4 address has 4 different spaces, essentially, like 0.0.0.0. So we print we get the first 3 numbers that could be between 0 and 9. We do that 3 times in a row, and the dot is just the separator, essentially. You don't have to know what this means. You just need to know that this regex matches IPv4 addresses. I recommend that you just use Google to get the regex that you want, because memorizing a regex isn't easy. This is just a bunch of stuff. If you really want to dedicate time to learning types of regexes that you used often, that's up to you. That's totally your thing, but it's just unrealistic. In most cases, people just use Google for the regex that they want to use. It just makes sense. So if we run this, you'll see that it's now just taken exactly the IP addresses that have been trying to SSH into our system. It is as simple as that. Now, we will be using another type of regex that matches IPv6 addresses. So if we use use the same line, we'll get rid of the section between the quotations, and I will input my other regex that gets IPv6 addresses. These will be in plain text in the description as well, so you could just copy them as well. So this one is what the IPv6 regex is. It's a lot more complicated because IPv6 uses hexadecimal as well. So yeah, as you know, as all you should know, is that this regex is matching IPv6 addresses. That's what it does. So we're saying sudo journalctl-u ssh.service, so we're filtering the logs just for the SSH lines. Grep failed password only for SSH lines that contain failed password, and then grep-e means to pair it with the regex, and -o means to only show the output that matches this regex, and the regex is the IPv6 address format. So if we ran this, then you'll see all the IPv6 entries. You'll see here we have the IPv6 loopback address, the one that I spoke about previously. It is the same as 127.0.0.1, but the IPv6 version instead. And if we were to delete the O, we would get the whole line. So as you can see here, we get the whole lines that contain those IPv6 loopbacks, and also when you run IPv6, you also get the IPv4 loopback as well. So if you wanted to run if you wanted to match just the IPv4, the lines with IPv4, you would use the IPv4 regex up here, but if you wanted to get IPv6 and IPv4, you'd run the IPv6 and IPv4 regex instead. A way that we can kind of clean up the output of this command is by using additional commands like sort, and I'll make it a little bit bigger so it kind of lines up a bit better. Sort and unit-c. So essentially what this does is it counts how many times each IP address appears. So if you look at the command that I'm writing, you'll notice that I'm using the IPv4 regex. So this will only return the IPv4 addresses that we are wanting, as it will match to the regex format. So if we run that, you'll see that it is now sorted the IP addresses. You'll notice that the O is also included again, so that we just extract the patterns that match the regex, e.g. the IP address that we're looking for, and you'll see the sort and unit-c commands has sorted it in a way that we know we have 2 appearances of 127.0.0.1, also known as the loopback address, pretty much. We can also filter the logs for different things. We don't have to use, we don't have to use a regex. We could instead use awk, and then, so this will be for printing specifically usernames. and then we'll print, and then we'll come across again, and we'll put in brackets nf-5, close the bracket, and then close the braces, and then put another quotation again. We used awk previously in, I believe, module 4, so it's nice to come back to that. And if we run this, you'll see that we get the usernames instead. Now, here's the thing with that command. So essentially what nf-5 is saying is, well, nf means number of fields. So a field is, for example, how many words are together and separated by spaces. So if we look at this command here, right, just as an example, this sudo is separated by a space to journalctl. So they are independent fields. Sudo is one field and journalctl is another field. So this is field 1, sudo is field 1, and journalctl is field 2, -u is field 3, ssh.service is field 4, and so on and so forth. So what nf-5 means is to count 5 fields back from the end. This is because the usernames in logs, at least on Debian systems, is always 5 fields away from the end. You could say, when you look at a log, you could count, you know, up to the username, and you could just say, you know, oh, we could print, we could use awk print $, and then whatever field it's in. The problem with hard coding that is the logs change in length a lot of the time. Some logs include things that some don't. So if you were to use a fixed field, such as the 9th field, so awk print $9, so it would always print the 9th field, the username is common to be found in the 9th field, but a lot of the time it's not. And when you hard code that, sometimes it'll give you the username, and sometimes it'll give you something totally different, like, I don't know, it could be anything. It could say port, it could say the port number, it could say literally anything that's in a log line that is in that exact field. nf-5 is better because it counts backwards from the end by 5 fields. So as we know, the username is always 5 fields away from the end, so it makes sense to write the command print $, and then nf-5, because the username is always 5 fields from the end, so we use a command that checks 5 fields from the end all the time. So we will 100% reliably get the usernames we want. And we can see there's 4 attempts from Hacker and 3 attempts from Max. That would have been from earlier labs as well. Hello, this is me from the next day. I wanted to come back and I wanted to create a script for this module because I feel it is the best demonstration of a regex. And yes, it's a regex, not a regex. Looking back on things, I found out it's actually pronounced regex, not regex. Someone pointed that out to me, and yeah, so we're going to be calling it a regex from now on. So I'll also be creating a script, as I previously mentioned, to better show the actual uses of a regex. And yeah, so we'll be demonstrating that. I've already generated some IPv4 SSH attempts already. So let's just begin. Let's create a new file called, we'll just call it regex.sh. And then we'll give ourselves executable rights to this file as well. And let's begin. So we're going to be starting with a shebang, as always, to tell the system that we'll be using bash to run the script. We're going to come down and we're going to be printing kind of like initialization thing, like just a small message. We're going to echo, so we know what echo is, just a print, extracting IPs from failed SSH logins. And then below, we'll use the commands that we've covered already. Journal, ctl, -u. Actually, it's probably better off putting sudo at the start. Personally, when I've used journalctl in scripts, sometimes it works. Oh, it's weird. You're better putting sudo at the start. It's going to be different for everyone. It might not work. Get rid of the sudo. Run it with sudo, stuff like that. You're just going to have to keep trying things until it works. We're going to grep failed password, so we only get the lines that contain failed password, and then we are going to come over and we are going to be using our regex, the IPv4 regex, because I've generated IPv4 brute force attempts, so that's what we are wanting to scan today. And then we're going to sort as well and use journalctl-c to get a better, so that we just get, you know, the IP address that has tried to get into our system and how many times. Simple as that. We're also going to be extracting the usernames. We've already done that in the terminal, but we're also going to do it in the script the same way as we've just done this. So we're going to echo and extracting usernames, and then we come down again and then just run sudo again. Again, it is weird, but yeah, it just works like that. So starting again, ssh.service, because we're only going for the SSH lines here. Again, for the same lines that contain failed password, because we are targeting the same lines, we just want the usernames this time. And then we're going to use the awk command so that we print the 5th field from the back again, because that's where the username always is. So print, and then come across again. And then close the braces. Easy. Oh, sorry. And then sort. And then journalctl-c. Okay. And then if we try to run this, there we go. Simple as that. So we have caught the IP address 127.0.0.1, the loopback address 6 times, and we've had 6 attempts from the username hacker and 5 attempts from the username max. So that's how we would automate parsing the logs and using a regex as well to match different patterns in the logs. So thank you very much for watching. Thanks for your time. Help us on GitHub if you're struggling, and I'll see you later.